Hello there, my name is Simon and I am the game director here at Far North Entertainment. Welcome to Far North Entertainment's first devlog, Far North Z. Some of you might have followed our previous prototype and might be familiar with the following footage. This devlog will not be about this game, however. Tribes was not necessarily a bad idea, but was considered vast and hard to realize within a reasonable time frame. We tried to identify problems early during prototyping so that the concepts may be scrapped and replaced before it's too late. In this case, Tribes was just a mishmash of a lot of ideas that we had that would be really cool. We thought, the dudes in the simulation had thoughts and feelings and traits. They could plan for their actions, and we wanted this to be a deep simulation like the ones in Dwarf Fortress and RimWorld. In the end, it was deemed hard to create this within the time frame that we have. We are aiming to make a game in 6 months. So it was crashed essentially. The new prototype that we have been working on during the last couple of weeks has the new project name Far North Z, and it is aimed to be a cooperative multiplayer survival game in which the players has to scavenge a city while being hunted by massive hordes of enemies. There are also ideas of including some kind of base building or crafting system to the final concepts. We have been looking at a vast variety of different games in order to gather inspiration and ideas for this game. Some of these games include Project Zomboid, Diablo, Minecraft, DayZ, Left 4 Dead, everything from just casual crafting games to high-paced cooperative shooting action. We try to look at everything and find what could be good for this kind of game. However, we have come up with one core mechanic and one core feature of the game that we are really trying to nail early on during this prototyping stage. So right now what you can see is the prototype's current state, in which we have a pre-built map, which we have designed in order to give us more control over the flow of the enemies, the options of the players, the distribution of loot, etc. At one point we had procedurally generated maps, but it was scrapped, because we wanted control to actually make good level design rather than leaving that up to random algorithms. We also have a lot of enemies that can be simulated simultaneously while being synchronized over the network. These two parts have been the core of the work we have done the last couple of weeks. It's been the zombie horde, making it simulate properly with collisions and pathfinding and so forth, and also getting them synchronized over the network without having massive amounts of packet loss and while staying within a reasonable bandwidth. Then we also have zombie alert mechanics, like for example if the player shoots, the zombies will hear that shot and they will start pathing towards the sound source. Also the zombies, when they come close to the players, they see the players and they lock onto the players by seeing them, so they will essentially chase the players around. Then we also have shooting, of course, of weapons, and you can kill the zombies by shooting them. So we've been working hard on optimizing the network and the simulation. But right now the view is the bottleneck. We have really low frames per second when all the zombies are close to the players and are within the screen. So we have to work some on that. That will be the prime focus of next week, to get the view to speed with the underlying simulation and the network synchronization. Apart from that, we also will add some new content. We will try to get new weapon types, so we will have some kind of crossbow, which is silent but slow. It's pretty useless at killing a lot of zombies, but it won't attract their attention, so maybe you can use it to avoid zombies rather than kill them. And the reason why you would do that is that we will add ammunition, so you don't have infinite bullets anymore. So this is basically how we'll do this devlog. We will present and show some footage of the game in its current state, and then we will also briefly talk about our plans for the upcoming week and iteration ahead. This will be followed by a more technical section where I talk in detail about the different solutions to big problems that we encountered and solved. But before that technical stuff, if you're interested in following the development of Far North Z, or whatever prototype we decide to work on here at Far North Entertainment, feel free to subscribe to our YouTube channel and also hit that bell icon so that you get notifications whenever we upload a new devlog. As mentioned earlier, the core concept of Far North Z at this point is the large number of enemies that are to be simulated and synchronized over the network, which is what last week was all about. The goal is to be able to have thousands of individually simulated agents in addition to the players, and to have it flow nicely in terms of frame rate and network latency. There's been a heavy focus on optimization, which amongst other things included the complete replacement of Unity's systems for collision management and networking. The networking is especially important. We're using a C# library called Lidgren, which gives us a lot of control, and more specifically it allows us to run the networking on separate threads. The Unity networking won't allow us to run the network traffic on separate threads. It has to be the main thread, which was a huge problem because it would slow down the view thread, which also renders the scene. So we could save a lot of performance on rendering by moving out the networking to this other library. Before we did this replacement, we could simulate about 2,000 zombies before we ran into major issues, and the game was basically unplayable because the zombies just stand around. They would update eventually, you know, like once per second, and that's obviously not acceptable. Right now we can simulate and synchronize about 6,000 enemies in real time, at which point the view thread becomes the bottleneck. When you have 6,000 enemies within the screen, that's when it starts to lag, essentially. The frame rate drops. So the simulation and the networking is deemed pretty acceptable at this point. We have separated the network threads, as mentioned earlier, in order to get more control of what happens under the hood. And it works as in this graph here. So we have a server, which has the controller, which basically updates the server model and whatever happens in the game. So the enemies are simulated on the controller thread on the server, for example. And then we have the view thread, which is what you actually see as the player. This is the Unity window, whatever it renders. So it renders the scene, the enemies, everything you see. It also reads the player input. So when you run around and shoot, this happens on the view thread. The view thread and the control thread has no connection to each other whatsoever. They don't know that the other one exists. They only communicate with each other by sending packets to what we call a connector. So there are 4 threads in Far North Z at the moment. We have the server thread, and then we have the thread on the server which accepts communication from the view thread. And then vice versa on the view thread, we have a connector that takes packets from the controller and the server and updates the view. And this makes it extremely easy for us to isolate everything that happens in the game. There is no mishmash between what happens in the view for the player and what actually happens in the code that simulates the game state. The networking was really the second big problem, performance-wise. The first big problem was to even simulate thousands of entities on a map containing walls and obstacles and stuff like that. And also having the limitation that these entities cannot collide with each other, and they are not allowed to overlap each other. The first problem here is pathfinding. In the beginning we used A-star algorithms, which basically allow zombies to determine where they want to go, and then calculate their own personal path to that target location. The problem with this approach is that it is linearly expensive. 1,000 zombies are 10 times more expensive to simulate than 100 zombies, because each path takes approximately the same amount of time to calculate. So the way we solved this was to introduce something called flow fields. What this does is that it covers the whole map in one global path that all zombies share. And this means that there is no longer a linear expense growth based on the number of zombies. The flow field is exactly as expensive to calculate for one zombie as for 10,000 zombies. So this means that the number of zombies is no longer relevant. So if we could just make the pathfinding for the flow fields efficient enough, it would no longer be a bottleneck based on the number of enemies in the game. So the second major problem here was that we wanted the hordes to feel like they actually are masses of individuals coming towards you on the street. So we don't want them to be able to overlap each other, and we don't want them to collide with each other. And having thousands of entities moving independently of each other and also making sure that they never ever overlap is a huge challenge. Unity's built-in collision detection system would just not it would not work here. It's just too big of a performance hit. So we had to find other solutions. We used a third-party library for this particular problem called RVO2, which helps us manage the agents. It simulates the agents and makes sure that they never walk into each other. I have no idea how it works under the hood, but it is pretty amazing. So that's it for this week. Hope to see you next week as well.